And what we're going to do before we start is do a recap of what we should have been learning so far. So, in the last class, we would have started chapter 9.2. And so the first question is, what are the two ways of representing an algorithm? What are the two ways of designing an algorithm?
Sir, by pseudocode and flowchart.
So Arifa says pseudocode and flowchart. Anybody else? Agree, disagree? What are the two ways of representing the algorithm? Yes, Tamika.
Sir, I agree with Arifa.
Alright, one more person. The rest of you agree or disagree? Alonzo? Agree. Morano agrees. Alright, good. So that is correct. The two ways of representing your algorithm, or we can design the steps of an algorithm, is by using a pseudocode or a flowchart. Now, how would you describe a pseudocode? What are the characteristics of it? You can see what makes up a pseudocode, or what makes up a flowchart, whichever one you want to answer, whichever one you can remember. What are the characteristics of a flowchart, of a pseudocode? How are they created? How can you tell the difference between the two? They have two major distinctions between them. What are they? Sierra? What's the distinction between a pseudocode and a flowchart? Akila?
Yes, sir.
What differentiates a pseudocode from a flowchart, or a flowchart from a pseudocode?
Sir, I'm not sure.
Alright. Amina?
Sir, a pseudocode does not use programming codes, while flowcharts do. Well, they use symbols.
You're heading there. You're heading there. So let's talk about the first thing you said. No flowchart pseudocode algorithm uses programming code. None of them. They're just simple instructions. They have nothing to do with programming language of the sort. But you said something at the end that is correct. One of them.
Yes, sir. The flowcharts use symbols while pseudocode use normal English.
Exactly. That is it. So these questions I'm asking you guys are simple questions, and these very simple questions come in your paper 1 exam. The flowchart uses symbols or diagrams, whereas the pseudocode uses normal English words. Same for the algorithm also. The algorithm also basically uses normal English word, but only the flow chart is going to use symbols or diagrams, or it's going to use shapes. Whichever one you want to use, whichever word you want to use, that is the differentiating factor between the two. The pseudocoding algorithm is going to continue to use English words, whereas the flowchart, as the name implies, this word here, chart, should give you that picture in your mind that it's referring to shapes, symbols, and so on. Are we following so far?
Yes, sir.
Yes, sir.
Yes, sir.
Alright, so next question. What should a algorithm, a pseudocode, a flowchart, what should they start and end with? An algorithm, a flowchart, a pseudocode, what should they all start and end with? Header. The header has a specific name. Michael? Maya? These questions are too simple for you guys to not know. What should a flowchart, an algorithm, a pseudocode start and end with? The end with the word end. Very good. So the end with the word end, or you can use the word stop. Either one can work. What does it start with now?
Sir, does it start with start or begin?
Okay, so the flow chart, let me just verify that for you. I think the flow chart is going to start with the word start. Yeah. So the flow chart starts with the word start or begin. But what is the algorithm? What does the pseudocode start with? They start with something different. What do they start with?
So they start with the word pseudocode and algorithm.
Yes, but there's a specific name for that part. Something specific we call it. A very simple word. What does a chapter start with? What does a book start with? A title. Very good. So, not a word. It starts with a title. These are very simple things that you guys need to remember for your exam. What do they start with? So firstly, your pseudocode, your algorithm, and so on are going to end with the keyword end or stop. All of them are going to use end or stop. But the flowchart is going to use the word begin or start. Whereas the algorithm or pseudocode, it starts with a title. So as Amina mentioned, it's going to look something like pseudo code add underscore tree numbers. That there is an example of a title. So you're creating a pseudocode. If it was an algorithm, you would have saw the word algorithm. But then after the colon, we have the title of that pseudocode that we're creating, and this indicates the start of your algorithm or pseudocode, whichever one you're creating. So your pseudocode or flowchart, those are the two ways to represent your algorithm. What's the differentiating factor between an algorithm and a flowchart? One uses English words and one uses shapes and diagrams, and these aspects here that we just mentioned. What else did we look at in the last class? Alright, so we have two terms. What is a variable and what is a constant? Who's going to tell us what's the difference? What are they? So Arifa says a variable is a container that holds a value that can change. A variable is something that varies. Anybody has anything else to add, or do you agree with that? A piece of data that varies, values of the constant doesn't change. Anybody else? Holds data, good. You can describe that as overall. So basically, a variable or constant holds or stores data. So that's their overall definition. That's their overall purpose. Their goal, their aim is to store data, to hold data. Now, the difference between a variable and a constant is basically how long is it going to keep the data now. So as Arifa and Akhilesh mentioned, so a variable is going to change and a constant, a variable changes throughout the program. Let's use the word program. And a constant remains the same. A variable, that's supposed to be changes, plural. Variable change. Variable is one. Anyway. So that's the difference there between the two. A variable, that's supposed to be changes throughout the program. Anybody agree with me, or is just me reading this incorrectly? Isn't changes supposed to be an S? Changes? A variable changes throughout the program?
Yes, sir.
Either way, good. So a variable changes throughout the program, so it holds that data. So say for instance the variable has it's equal to 10, then throughout the program that variable could change to 20, that variable could change to 1,000, 10,000. Throughout the program is going to change. Whereas a constant, it is going to be that one value throughout the program. No matter which part of the program, is going to continue to use that one specific value. So that's the difference there between the two. So why do we have this variation here? Well, basically there are some situations where you will want to change the value in a variable. Like for instance, if you have a variable called price, and you're accepting price for various items, then obviously it's going to change depending on the item. So it has to be a variable so that it changes to reflect the item that it is for. But for a constant now, an example of that might be discount. So discount now, that is going to remain the same for a particular item. So for instance, if you're selling shoes, they might have 20% off, and that's going to be that 20% off for all shoes or a particular brand. If you have appliances, it might be a 10% off, but it's going to be that fixed amount. It's not going to change until there is no more discounts. That discount period has ended. So that's a situation where you're going to want to use a fixed value. You don't want that percentage to change throughout the calculation. You want it to remain the same for all the calculation. So that is why you have a difference in how you're storing data. Some situations you want it to change, some situations you want it to remain the same. Are you guys following? So the next question, what are the types of data? That's the last thing we would have looked at in the last class. What are the types of data? Sierra? Ashley? Nobody? What are the types of data? It's like, y'all remember nothing from the last class?
Sir, there is the integer, real, string, and char or character.
So we have integer, real, string, character, and Boolean. Good. So give me an example of any one. That one is with yes or no, correct? So Boolean is when you have two answers. So So when you have only two answer or only two responses, so for example, yes or no, we're not looking at maybe, yes or no, on or off, two completely different states. You could think of it like a light switch. How many of you have ever tried to put the light switch directly in the middle? You ever tried that? Putting the switch directly in the middle? And when you try that, what happens with the light? Does it go in a state between on and off? Or is it going to still be on and off? Only on and off. What happens with the light? It can still be on and off. So it's only, it's either it's going to stay on or it's going to stay off. So even if you do get it in the middle, the switch stays in the middle, the light is going to remain in that state, either in on state or off state. Doesn't matter which one. So there's some data that only has two states, either it's on or it's off. So that's the Boolean there. Now what's character, string, and integer?
Sir, character is a single like letter or symbol or number. String is a combination of those letters, symbols, or numbers. A real is like a decimal. An integer is either a positive or a negative number.
Try again for integer.
A positive or a negative number.
So real can be positive or negative.
Yeah, but
a whole number. Very good. So an integer is a whole number, whereas a real is a decimal, and both of them can be positive or negative. The difference is basically which one can store a decimal place. That's the only difference. Both of them have the same range of numbers, the same negative numbers, the same positive number, but the only difference is that one represents decimal places. Same for string and character. Character can use all of the letters and symbols and numbers, everything it can use, but it can only use one. It can use a single character. Whereas a string, you can combine multiple of them together. So this is the basics of what we would have covered in the last class. Please ensure you remember this here. These information is very important, especially for your exam. Now, if you guys don't have any questions, remember, at any point in time you have any question, you can let me know. The purpose of these classes is not just for me to teach, it's for also to help you to understand. And the only way you can understand is if you clarify your questions. So, if you don't have any, we're going to move ahead. Now, so this is where we would have left off. We started chapter 9.2, so this was the information I was reviewing here. So this is the pseudocode and flowchart. This is the variable and constant we were just talking about, and this is the types of data that we were just talking about also. So we're going to continue from this paragraph here. Now, when you are creating a variable must have a name. So you should give a variable a meaningful name. So it's not like how people would give the children any name, any sort of name today. You name a child North, you name a child South. Pretty sure somebody has the name East and West. So it's not a case whereby you're gonna look at the name and you're gonna wonder what is going on with that person. So when you're looking at this variable name, you're supposed to understand what type of data is being stored. For example, in your database, if you can remember your database, you have a field. So whenever you hear the term variable, you can also think of field in database. It's kind of similar. You have a field called first name, and that tells you exactly what is being stored, somebody's first name. You had a field called lot. That tells you exactly what is being stored there. Even if you named it lot number, that is telling you exactly what is being stored in that field. So similarly, when you create a variable, you're going to give it a meaningful name. So in your program, you should use meaningful variable names in your program, so that if you or someone else needs to review the logic of the data being processed, then the variables will be easy to understand, easy to remember, and easy to understand. So your algorithm is not only for you to read. Remember, your partner has to read it. Whoever is reviewing it has to read it. I have to review it. I have to understand what is happening there. CXC has to mark your SBA all over again, and they have to understand what you're doing with this variable. So you have to use meaningful names, so whoever is looking at it should be able to know that this variable is being used for this purpose, and they have a good understanding of it. So did I show you guys how to create a pseudocode? Did I give you a guide as to how to create pseudocode? I think I would have given that in class, but anybody other than Morano, did I show you guys a guide as to how to create a pseudocode? No? Alright, so tonight we are starting with how to create a pseudocode. So I already showed you guys how to create an IPO chart. So this here is an IPO chart, a table basically showing input, processing, and output. You guys remember that? So I already showed you how to develop that, and you're actually supposed to start creating that for your SBA. You're actually supposed to look at your SBA, go to this first part here and read this paragraph. So this is problem solving and programming. You were supposed to read this first paragraph here and create your IPO chart. Have any of you done that? Or you didn't know you had to do that? Alright, so that means I would have already told you. So even for class 2, I would have mentioned this. You got to read this paragraph here, and you're going to start creating your IPO charts. So please ensure you start that also. Basically, we're doing the programming SBA in steps, small pieces at a time. So start your IPO chart, and you're supposed to actually also start your problem definition for your SBA. I would have also taught you how to create a problem definition by specifying what's the input, what's the output, what's the processing, what's the storage, what were the other questions? What is the issue? What caused the issue? And what are the effects of the issue? All this information would have given you already, and you're supposed to start the problem definition for your programming SBA. So 2 things you actually have to start, or you're supposed to have already done for your SBA. Now today we're going to be looking at, after you would have designed that IPO chart, that is where you're going to start creating your pseudocode for your program in SBA. So I'm going to be showing you how to create a pseudocode. So I have a guide here. I'm going to send it in the group. Let me send it one time so that hopefully my computer doesn't crash. Please don't crash. Please don't crash. Where's the group? Where's the group? Alright, so that document there is what we are looking at currently, that is sent in the group. It's basically a guide that I created as to how to design a pseudocode. So, as we said already, the first part of your pseudocode is going to be your title. So, pseudocode, add 3 numbers. So this is a pseudocode. If you look at the top here, this is a pseudocode for adding 3 numbers. This is the purpose of the program. Pseudocode for adding 3 numbers. So we have a title, and this is just a comment outside here. This indicates the start of the pseudocode. So this title here, so the title indicates the start of the pseudocode. Now, after you would have created your title, what you're going to do next is enter a part of your pseudocode called the variable declaration. So you could have either called it declaring variable or variable underscore declaration. Either one can work. It's basically you declaring your variable. What does the word declaring mean? When you declare something, what are you doing?
Sure, state.
You state something. Looking for another word. When you state something, what are you doing?
Sir, you're giving the purpose?
Looking for something specific. When you state something, when you tell somebody something, when you declare something, what do you expect from the person? If you tell somebody something, what do you expect this person to, how do you expect that person to react?
You would expect them to like respond to it or like carry out the action that you asked them to.
So in order for them to do that, what will they have to do about your information?
Process
or
analyze,
acknowledge, or I was looking for more of to indicate that they understand what you would have said. Or you can say declaring means to make known, to formally announce the beginning of, to pronounce something. Basically, in a nutshell, we could say to make something known to that person. So whenever we say declaring variable or variable declaration, what that basically means, you are making known the variable. So making known the variable by stating the name of the variable and data type of the variable. That is how we declare the variable. You have to make it known by stating what is the name of the variable and what is the data type. And we already looked at this here. So that's why we already went through this here. So we already learned that the variable name must be meaningful, and the data type, we already learned what are the 5 data types that you're going to be using. So the question now is, how do you put it into the pseudocode? So this is an example of how you do that. So the purpose of this pseudocode is to add 3 numbers, number 1, number 2, and number 3. So what we did is simply name the variable exactly representing what we're entering. We are entering the first number, so we name it number 1. We are entering a second number, so we named it number 2. And we enter in a third number, and we named it number 3. So this is the name of the variable. On the left hand side of the equal sign is where you are stating the name of the variable. So name of variable before equal sign. You guys following so far? Anyone not following? Anyone with any question? Now, after the equal sign, so you put the name of the variable and you basically say what data type it is equal to. So the data type is after the equal sign. So if you notice, it's using that same data type that we would have learned, integer. And we know what is an integer. An integer is basically a whole number. Now if we wanted to accept numbers with decimal places, so say for instance 5.29, 10.10, what would the data type, what would I have to type here as the data type? Real. Very good. So I would simply have to replace integer with the word real, and that is basically me indicating that this variable here called number 1 is being set, is being declared as a real data type variable. Are you guys following? The rest of you following?
Yes, sir.
So let me put this back as integer. No. So this is declaration here. So if you notice, I created a 4th variable called total. So this name of the variable is total, because obviously when you add the 3 numbers together, you have to store the result somewhere. So where are you going to store it? You can't just store it in here. You got to store it in what can hold data, which is a variable. So we have to create another variable. So we're going to create a variable called total, because that signifies what we're doing. We are getting the total of the addition of these 3 variables here. So we're going to call that now an integer data type. So we're basically declaring our 4th variable here. Now we have another variable here. This here, if you notice, I'm declaring a phrase and it has a string data type. So if you notice, it's a pattern. You basically put the name, the equal sign, and whatever the data type is after the name of the variable. The only difficulty you should or you will have, you can have, is deciding what data type to use. That can be the issue, because you have to select what is the most appropriate data type. And since we already know what is the difference between each data type, you basically just have to deduce, if I am only accepting whole numbers, then I'm going to use integer. If I need to accept decimal places, number with decimal places, I have to use a real data type. If I'm going to only accept a single character, I am going to use the character data type. If I'm going to accept a word, if I'm going to accept a phrase, anything of that sort, I am going to use a string data type. So you have to figure out what is the data that's going to go in the variable and choose the most appropriate data type. It's the same thing you would have had to do in database. When you created that field in database, you would have also had to select a data type, a field type, basically the same thing. And you would have had to determine which is the most appropriate. So like for instance, you enter in a phone number, we know that the most appropriate is text. If you are entering the price for an item or the gross income, you know that that's money, so that's going to be currency. So you have to choose what is most appropriate. So this here, once again, this is variable declaration, or declaring the variable. You state the name of the variable and what is the type of variable. If anyone with any questions, you can let me know. Alright, so continuing, if no questions. Now, one thing to note is that you have to be careful with when you're storing, like for instance, when you're adding these three variables together, you have to be careful when they're going to be stored into another variable, because that can cause error. What do I mean by that is, let me get a Word document open. Good. I'm going to make it simple. We have a whole number. Can you store a whole number into a decimal number? So we're talking about the way we represent whole numbers and decimal number. Can you take a whole number and represent it the same way as a decimal number? Can that work? Will it be the same value? And you can think of it the other way. Now, so the answer is yes, you can, because if you take the number 10 and you store that in a decimal format, it's going to be 10.0, or how much ever zero at the end. It could be 50,000 zero, and the fact is going to remain, it's still 10, because everything after it, everything after the decimal point is 0, doesn't have a value. So both of these are the same thing. Now, can you take a decimal number and store it into the place of a whole number? Anyone else? Can you take a decimal number and put it in the place of a whole number? No. That is correct. The answer is no, you cannot. So, using the same example, but say we have 10.50, and we take that now and we store it into a whole number, it's going to appear as 10. Now, are these two numbers the same? No, they're not the same. 10.5 and 10 are totally different numbers. One is a whole 0.5 difference from the other. So, with this in mind, this is what can cause error in your program. This is what can cause error in your pseudocode. And this could even be a question. It can actually be a question on your paper. Because what it can actually do in your exam is show you a pseudocode. Just like how you're going to see I have a pseudocode like this here, looking like this here. They can show you a pseudocode as a question. And they can ask you, why is it not working? Or they can ask you if it will work. And or they might ask you, what is the error in the program, in the pseudocode, whichever one. So this is one scenario of there being an error. So we just learned that you can store a whole number into a decimal, but you cannot store a decimal into a whole number. So if we interchange that with our data type, so that's going to be, you can store a integer data type into a real, but you cannot store a real into an integer. That's not going to work. You cannot store a real into an integer. So these two here, let me put them close by instead. Good. So like that. So you can store a whole number into decimal. So in terms of our pseudocode, you can store an integer into a real. That's for the data type. The next one, you cannot store a decimal into a whole number because it's not going to represent the full number. So that means you cannot store a real into an integer. So what I'm getting at is, for instance, if we go back to our algorithm, our pseudocode that we're creating, right here where we are declaring these variables. So these 4 variables here right now, just focus on these 4 variables here. So these 3 numbers here, they are integer. So if I turn this total into a real data type, will I get an error? And why not? Good. So the whole number can be stored in the decimal. Now, if I interchange it now, if I say this is an integer and this one here becomes a real, so I just change one of it, will I get an error? So yes, I will get an error because we cannot store a decimal place number into a integer. We cannot store a real into an integer. We cannot place a decimal number into a whole number. Even if the decimal number has zeros at the end, it doesn't matter, because the system is not checking for that. The system is not checking if it's a zero at the end. It's not checking for what is the value. It's checking for the fact that it has a decimal place. So the fact that it has a decimal place, it doesn't know how to represent it into a whole number because it has to keep that specific value. So in this situation here, it will not work. Your program is going to give you an error message that this here cannot work. So the only way it can work is if, how would you fix this here? That could be a question also. So this here is going to give you an error. We have two ways of fixing this here. What are the two ways? Can you think of the two ways? Two ways of fixing this here.
Sir, we'll change the integer to a real, or we could change it to a string.
So change this integer here to a real. That is one. You can't change it to a string, because string is going to only be for character, and even though character has numbers, it won't be used in calculation. So the first one is correct. We're going to change integer to string, integer to real. What's the other method? So we change this to real. That's one method. What's the other method? Change the real to integer. Very good, that is it. So you change back all of these here back to integer. So basically, if you notice, when you're doing calculation, you would try to keep all of the number data type to one specific data type. So if you're only going to want to work with numbers, whole numbers, then you strictly put integer. But any point in time you want a decimal number, you want to show decimal places, then you're going to need to represent it with that real. But we already know that you can't put a whole number into a real. We already know that, right? So nothing is wrong if you had made all of these integer and you made this last one here a real to show the decimal place. Nothing's wrong with that. So you accept only whole numbers and then you make this a decimal place number. Nothing's wrong with that. But the only issue is that you can't go the other way. You can't go real into integer. Good. So that there is the starting of your pseudocode. We have the title, we have variable declaration, which basically is stating the name and the data type. Are you guys following? Good. Alright, so what's next? So that's the title, that's variable declaration. That's the error that you can have going from one data type to the other. And do you think the same thing can happen with character and string? Like what's happening with real and integer? You think the same thing is possible? Yeah, the same thing is possible. Because remember, this one here is basically one character, and this one here is multiple characters. So obviously, you could store the one into the many. The one that can store many character. But if at any point in time a variable has a string, then you can't store it inside of a variable that has a character data type. It won't allow you to store that. So that's another error that can occur there. So you gotta look. That's why it's important for you to understand what is the data type and what is the type of data it is storing, so that you can look at those errors that can actually occur. Now, after you would have finished declaring your variable, we are going to enter a stage called initializing variable, or we can call it variable initialization. So either one you can call it. I'm going to send back the documents when I'm finished. Yeah, so initializing the variable or variable initialization, whichever one you want to use. What this basically means is that you're given a variable a starting value. So given a variable a starting value, you tell it what is it going to start with, what value is it going to start with, what is going to be, what is it going to store when the program starts off. So for instance, we could say that number 1 is going to start off with a 0, number 2 is going to start off with a 0, number 3 is going to start off with a 0. And if you actually notice, it's similar to the declaration. You say what is the variable and you say what is the value. So name of variable before equals sign, and then starting value of variable after equals sign. So before the equal sign, you put the same name of the variable that you have at the top here. So with that in mind, I want you to note that you cannot initialize a variable if you did not declare it. Please take note of that. So let me put that here. You cannot initialize a variable if it has not been declared. Very important to note. You cannot initialize a variable if you did not declare that variable. The purpose of declaration, the purpose of variable declaration is to declare something. It's like if you after you finish school, or say for instance you're going to school tomorrow morning, you declare that you're not writing Spanish anymore, you're not writing French anymore, you're not writing Portuguese anymore. You declare that I'm not doing these subjects anymore, I'm not writing IT anymore. You're making it known from the very beginning. That's the purpose of declaration. You're making it known from the very beginning, so that throughout the program it's going to know that these things exist, that this is what is happening, this is what is going to be used. So if in the beginning you did not create a variable then you cannot use it later on because it was not declared in the first place. So you cannot initialize if you have not declared. Now, this statement here, it's only true for basic programming. Just note, this is a side note. This is not a exam-based note. This is a side note, a technical note. Now, this is only for basic programming. If for any one of you, if you're interested in computer science, if you're interested in IT, say for instance you're interested in programming, there's some programming languages that bypasses this rule, that you can't use a variable without declaring it. There are some programming languages like that as you go through the program, you can make use of a variable right there and then. You don't have to declare it at the beginning of the program. But you guys are learning the basics of programming, so that's why we're telling you this is just for the basic. This is not for advanced level. This is just for the basic, that you must initialize, you must declare before you can initialize a variable. And what is initializing? Initializing basically means you're giving the variable a value. So basically what we're saying, you cannot give something a value if it does not exist. That's all we're basically saying. And the only way the variable exists is if you declare it. Are you guys following? Alright, so I have an example of declaring a string. Not declaring, initializing a string. Remember, initializing basically means to give a variable a starting value, what you wanted to start off with. So for instance, doing that for numbers, that kind of makes sense. You might want it to start off with a specific number. Now, you can do that for a string, you can do that for a character also. So this is how you would actually do that. You would put the same variable name in the beginning, equal sign, and then in quotation mark, what is the letter, what is the symbol, what is the words, what is the sentence, what is the phrase in quotation mark. That's how you would initialize characters, basically. So this here is an example of that. So if you wanted a single character, so say for example word equal A, or let me use the word grade. So grade equal A. That's how you can initialize that that variable grade and give it a letter A inside of it. It starts off with the letter A. At the top here, grade equal character, because I got to declare. Good. So that is declaring, that is initializing. Now here's a question. Let me see if anybody figure it out. We would have learned that we have to use a variable and a constant to store data. And if you notice, this literally says declaring a variable, initializing a variable. Now the question is, how do we create a constant? How do we create a constant? And it's actually very simple. And we've actually already done it. How do you think? you would create a constant. You could ask yourself firstly, what is a constant? And that should give you an idea. Anybody wants to try? No one? Alright. So, review. What is a constant? Somebody remind us, what is a constant? It does not change. Now, there's something very important I want you to note. Not sure. I think I would have mentioned it. But more than likely you guys don't remember it. Please note that a constant is actually a type of variable. A constant is a type of variable. So what that basically means is that we already know a variable is a container that stores data and that is going to change throughout the program. So if a constant is a type of variable, that basically means that a constant is a variable, but instead of changing throughout the program, we are going to let it keep its value throughout the program. So if you think you're following, creating a constant is actually just as creating a variable, because a constant is a type of variable. So basically, we've already created a constant. Can any of you tell me or make a guess as to where we have a constant here? What do you think? Where do you think we have a constant? Total? Which one? We got two total. For all the numbers. What do you mean by all the numbers? 1, 2, 3. So we talking about this here at the top. We talking about this here. What exactly?
Okay, so basically, yeah, from number 1 to number 3, the variable, whatever displaying is 0, and that is a constant.
Good. That's exactly it. So all of these here that you're seeing here, where I'm initializing the variable, I am basically creating a constant also. So initializing is also basically creating a constant, because what I'm doing is basically giving it a value. Now, remember, a constant is something that does not change. It's a variable that does not change. So that definition there is actually it's not telling you exactly what happens. It's not telling you exactly what happens. It's not that it does not change. It's the fact that we do not change it throughout the program. That's the correct term we should be using. That's the correct phrase we should be using. We do not change the value throughout the program, basically. So now that it does not change, we do not change it. So the fact that it remains the same because we do not change it. So if, for instance, this number 1 remained 0 throughout the program, and I never took a number and stored it into number 1, that is going to be a constant. This for number 2 also. If I never took a number and store it into this variable called number 2, it is going to be a constant because it's going to remain as 0 throughout the program. Same thing for total. If I never took a number and store it into total, if I never did a calculation and say store it into total, then it is going to be a constant. It's going to remain that value throughout the program. Are you guys think you're following? So I'm going to repeat. It's very simple. So we're saying that a constant does not change. So it's not that it does not change because there is some setting that says it will not change. It's not something in the program saying or forcing it or to keep it the same way all the time. Nothing is forcing it to remain the same all the time. Why it's remaining the same is because we are not changing it. We are going to do all we can to keep it the same value. So say for instance, we have a variable called VAT, and we say this variable starts off with 16. Say this variable starts off with 60%. Then throughout the program, we are not going to store any value into this variable called VAT because we do not want to change the 60%. So because we're not going to trouble the value inside of it, and the fact that it's going to remain the same, it is going to be called a constant. So once again, it's not that it's going to remain because something is forcing it to remain. It's the fact that we are not going to change it that's going to make it remain the same. Did that help, Tamika? Alright, so hopefully the rest of you understand. Now, so all of these here, once again, are constants. But basically, at the starting of the program, they're constant. But basically, throughout the algorithm, we are going to be storing values into them. Because if you notice, for example, here, input number 2, I'm basically storing something into number 2. So the variable is going to change, hence it's a variable. It's not going to be a constant anymore because I'm putting something inside. For instance, here also, I'm adding number 1, number 2, number 3, and I'm storing it into total. So total is no longer a constant. The value is going to change, so it's now going to become a variable. So unless it stays the same throughout the program, for instance, if I put back that VAT equal 60%, and I run through the algorithm, I run through the program, and I see nothing puts a value into VAT, nothing stores a value into VAT. It remained at 60% all the way to the very end. It is a constant because it remained the same, basically because we did not trouble it. So if no questions on that, one thing that I just noticed about naming your variable, you have to be careful with case sensitive words. Try to name it exactly as you would have created it. So for instance, if you notice, I have a total at the top here with a capital T, and I have a total at the bottom here with a common T. So that shouldn't be the case. I should have both of them with a capital T. And then the same for phrase also. I have it with a capital P. So at the bottom here, I should have it with a capital P also. So ensure your variable names are case sensitive. Whatever you would have made capital, it remains capital throughout the program. And try to ensure you use the correct name throughout the pseudocode. So if you named it number 1, don't go and type number space 1. That's a totally different name. Or if you named it number 1 with no space, don't type later on number underscore 1. That's a totally different variable. So you got to ensure you're using the correct name for your variable throughout your pseudocode, throughout your program. Now, so that there is declaration, that's your title, that's initialization, that is the constant given a variable of value. So I'm going to put it aside here. Note initializing a variable is also creating a constant. So basically initializing, you're creating a constant. But remember, once again, if you change the value, it is going to become a variable. And why I'm keep using that term, remember, a constant is a type of variable. The fact that if it's going to remain the same, it's going to be a constant. If it changes, it is going to be a variable. Now, let me see if I missed anything here with initializing. Okay, now if you notice, I ended each line with a semicolon. That is not necessary. The semicolon, the purpose of the semicolon is to indicate the end of a line. Indicate the end of a line of code, a line of instruction. So this is one line, this is two line, this is the third line, this is the fourth line. And the semicolon is usually used to indicate the end of the line. But it's not necessary for you to type it. Because later on, when we're going to use a function called if, the same thing you would have learned in spreadsheet, if then and if then else, it might confuse you there as to where to put the semicolon. So when you're developing your pseudocode, you can leave it out so that you don't run into any mistakes with that. But if you want to put it in, you can put it in also, and when it comes to that if part, I'll guide you as to where to not put the semicolons. Now, so that's for the semicolons there. Now, one thing to note, when you are declaring and initializing, there's another way that you can actually create it. There's another way that you can actually write it. So, if you notice, these three here are actually the same data type. So, because they're the same data type, we can actually write it in the same line. We could say number 1, comma, number 2, comma, number 3, comma, equal to integer. That way, we save line spacing. So, we can either do the method above or this method here. Either one can work. But if you don't know how to combine it into one line, the safest thing to do is just separate them individually into their own line. Nothing's wrong with that. Same thing for the initializing also. If you notice, those three numbers here, they're basically the same thing. So we can do the same thing also. So, or number 1, comma, number 2, comma, number 3, comma, equal to 0. So all three of them equal to 0. All three of these here equal to integer. Now total here also equals to 0, so we can actually add that in also. So once they're the same data type, once they're the same starting value, the same initializing value, you can type them in the same line, and that way you can save space and so on. You guys understood this here? Clear on this here? Clear so far? Alright. Alright, so I'm not gonna go further pseudocode. So you guys can actually also start this part of your pseudocode also. So you have 3 things to start that you can actually start working on for your program SBA. The IPO chart, the problem statement, and you can start the very first part of your pseudocode. You can start creating your title, you can start declaring your variable, and you can start initializing any one of your variables that you might need. And this is where creating your IPO chart can be important, because if you create your IPO chart correctly, then you can simply transfer over those variables into your pseudocode, because that's the purpose of the IPO, to basically know what variables you need. So that's why I'm actually telling you to do the IPO first, so it gives you an idea as to what variables you basically need. Alright, so going back to the chapter. Alright, so we're gonna finish off with these few paragraphs here. So the next topic is basically what is a statement and what is a keyword. What is a statement and what is a keyword? Now, a statement is a description of the processing. Can anybody explain to me what does word processing mean in terms of IT? A very simple word. What does that word processing mean? Calculating data. Alright, so here's what we're gonna do, because I actually want to go into explaining this part of it. Alright, so I think we covered enough information, because this here can actually go into the other part of the pseudocode, which is actually this part here, input, and that's a lot more information to cover. So so let's just recap what we would have learned tonight. So tonight we would have recapped last week's work, which is very important for you to remember that when you're designing an algorithm, you have 2 ways of creating that algorithm. You have a pseudocode, or you can use a flowchart. Flowchart, please remember they use diagrams, shapes, whatever term you want to use, and a pseudocode uses English statements. This section here describes what makes a pseudocode, a algorithm, a flowchart effective. It must be correct, it must be simple, it must be clear, precise, easy to implement, it must be efficient. This is important for exam purposes. This is like the characteristics of a pseudocode, the characteristics of an algorithm. We learned what is a variable, what is a constant. Remember, variable, both of them, the purpose of them is to store data. That's the purpose of both of them. But the difference is that one is going to change, one is going to remain the same throughout the program. We learned about our various data type. So you got to remember which one to use, which one to not use, which one you can combine together, which ones you can combine together, and so on. We learned how to create variable names. I would have mentioned this in the last class, but I'm going to repeat it again. Remember, your variable name should have no space. So you should have no space. You can use an underscore. You can use a period. In some cases, you can use a hyphen. but no space at all. If you're not gonna use any symbol, then the second word, the third word should start with a capital letter, basically, to indicate the next word. We looked at how to create a pseudocode, so we started at the very beginning. I showed you how to create a title. I showed you how to declare your variable, and I showed you how to initialize your variable, which is basically creating a constant. Alright, any questions on anything we looked at today? Questions going once. Questions going twice. Alright, if no questions, please ensure you are following through on everything that we're looking at. Remember, programming is very serious. Programming is one of your major parts of your IT exam. I've already told you guys it's the difference between a grade 1 and any other grade. Grade 2, grade 3, that can give you the difference between a grade 1. So please ensure you're following through, and especially for the SBA also. Alright, if no questions on anything, we're going to close off here for tonight. Enjoy the rest of your night. See you tomorrow. If you want me to check your SBA,